In general, there are 4 ways that we can target influential persons with interventions beyond just random selection. First, we can survey everyone, ask who they think is influential, compile all the answers, and then select the most central individuals based on some definition. But while this is sound, it's also quite resource intensive. Second, we can just ask key individuals in the community, such as government officials, teachers, or priests, who is influential. And we find that this works fairly well, but it can miss segments of the population ethnically or socioeconomically. Third, we can survey random individuals and ask them about their own level of influence, but certainly this may be a biased estimate. And fourth, we can actually observe network exchange, as with cash flows through a banking network or information exchanges in an office, but this is often prohibitively expensive or in some cases logistically impossible. In this study, they actually try a version of number 1 in addition to simple random sampling in a control group, but they find that it doesn't work well for reasons that have already been discussed. So in this presentation, we'll examine how friendship nomination fits into the picture as better than simple random selection, but as a non-resource intensive, unbiased, and feasible alternative to some of the options listed here. The friendship paradox is explained in the paper as the idea that your friends have more friends than you do, and this is used as a rationale for why friendship nomination works. A mathematical proof of the friendship paradox is probably a bit much for today's presentation, but I want to walk you through a practical example of why friendship nomination works that should help clear up any confusion. The best way to understand friendship nomination is to know that it works because, on average, those with more friends are more likely to be named as a random friend by those friends. This follows from the friendship paradox of your friends have more friends than you do, but I think the explanation here helps us understand friendship nomination more clearly and why it works. And the key to remember here is that people aren't naming their most influential friend or anything like that, just a random friend. So here's an example. If we look at this network with dots being people and lines indicating friendships between them, it's probably clear that some people are more desirable targets to spread an innovation than others. So let's look at how random versus friendship nominated selection works out. First, if you choose a person at random, each has a 1 in 6 chance of being selected, which is a probability of about 16.7%. Now, if we have each person choose a random friend, we can see that number 1 has a very high chance of being selected, 50% from person number 2, because person number 2 could choose either number 1 or number 3, also 50% from number 3, 50% from number 4, and 100% from number 5, because he doesn't have any other friends. This comes to about a 41.6% chance of being nominated. Compare this to person number 5, who only has a 25% chance of being chosen by number 1, as there are 4 people for him to choose from, or about a 4.2% chance of being selected in total. I filled in the rest as you can see on the slide. We can see why friendship nomination works in the graph pictured here. People aren't choosing number 1 more because they consider number 1 influential. Instead, there's just a greater likelihood of him being chosen as a random friend. And this is true of any network, but the effect is especially powerful if the distribution of friends is more varied, as it often is in human interaction networks. This helps us understand why friendship nomination is helpful in targeting interventions. This sort of nomination scheme has already been shown to be effective in disease outbreak monitoring, so it will be interesting to see where else it is applied and what modifications might even improve the effectiveness of interventions. So to put this study in perspective, there are 2 main ways it's important to us. One is that it's experimental, not just observational in nature. Social network analysis has been around since the early 20th century, evolving from a qualitative study of small groups by sociologists to bringing computational analysis to bear on large data sets in biology and physics, and taking advantage of network data made available by computer networks. But starting very recently, there's a trend to move from simple observational studies of which network or non-network variables might be associated with other network or non-network variables to experimental studies, and this study is a great example of that. Secondly, while many network methods use whole network data, which can be expensive to collect, interventions based on the networks of individuals are fairly rare. So it's exciting to see a practical method like this coming from social network analysis. Hopefully we'll see many more like this in the near future, perhaps asking people to nominate influential friends, or following multiple nominations, or trying methods other than a random initial sample, or many other possibilities. By the way, as a final note and shameless plug, I'm a potential PhD candidate at the London School of Hygiene and Tropical Medicine interested in studying these possibilities, and only lacking the partnership of an organization interested in supporting a study like this to get started. So please let me know if you'd like to discuss how social network analysis might help improve your programming. Thanks.